Hello, you wonderful people. This is the next episode related to thermal physics. We continue doing a gas state equations problem. The basis here is the ideal gas modeling and the gas state equation itself as the main formula. However, we go to gas mixture problems. This is now the class of the problems. As you understand, each problem basically represent a specific class of questions and problems related to different parts of thermal physics, but still within the gas state equation and within ideal gas. All right, so that's why it's the right time to remember that gas state equation looks like this way, where new number of moles. However, right now I just want to clarify the case when we have a mixture of gases. So first of all, when you hear, for example, oxygen, say oxygen, it means that, and according to the chemical or chemistry basis, we understand that it's going to be the molecular. If you're not clear, say that this is molecular, so make sure you understand this way. So for example, what about helium? Helium can be in atomic state, so we can consider helium as it is. What about hydrogen? That's definitely H2, right? And that means in terms of molar mass of 1 mole, right? Because by definition, number of moles, it would count as 1 and just go by definition as mass over the molar mass. In this case, we have that is number of grams and 1 mole, right? And 1 mole of substance. So that means, for example, for H2, the molar mass, according to a periodic table, should be considered as 2 grams per mole. Okay, what about oxygen? So oxygen, simply an atomic molar mass is going to be 16. So for 2O2, oxygen 2, we multiply by 2. So that means it's going to be 32 grams per moles. All right, so that's consideration will help us. But right now we're going to go to and consider a mixture of gases. So what's the law lays behind how we take into account, for example, pressure, how we take into account the total mass. So in terms of mass, it's pretty obvious, right? Since we have a mixture of gases, we just simply need to add each component mass if we have n components. So let's say n type gas, n types of gases we have a mixture. So we just simply add them up. So another way around to show that, we just sum up mi's in order to get the total mass. But what about the pressure? So how would you use the normal, the normal equation for the gas state? In this case, we consider that if we have the volume within which we have different types of, let's say, atoms or moleculae, and let's say greenish one, right? So for these 3 components substance, we need to simply consider the total pressure as the sum of each pressure in particular, all right? So for n components, so if we have n components, we just simply add up to Pn. So another way around, we can use this equation for any particular number of components. So for any I, we can use this equation, Pi V equals nu I R T, because those components are in the thermal balance, means we have common conditions for them. So temperature, pressure, not pressure, so temperature and volume. But the pressure can be figured out using the quantity or number of moles from here, all right? And as a result, so the total pressure becomes simply the sum of all pressures, All right, so that's how we can figure out. So basically each component we can consider it separately. All right, so that was theoretical basis that lay behind the scene. All right, and we can go and try to solve problems 3. So in the next video, I'll show a problem itself and we're gonna go through solution. Hope you like that. Don't forget to subscribe. That was pretty easy, and see you next time.